Welcome. Today I'm going to be talking about the National Football League Combine and that equaling performance. A little bit about me. I'm Ashlyn Hartman. I'm a senior mathematics and data science as well as a sports management degree. I spent the summer interning with State Farm this summer. I play volleyball and track for Millikin, and I'm also a leader for the FCA. I work as a math tutor and am a club volleyball coach. Along with that, I'm looking to pursue my master's after graduation in May and have a passion for sports and for analytics. So as a little bit of get to know you guys, how many of you are sports fans? How many of you like analytics? How many of you like football? All right, awesome. I hope you enjoyed. Today I'm going to be talking about the background, the motivation and purpose of this, the methods in my data, the results and analysis, and where the future looks. First, for the background. So the NFL Combine, it takes a look at your NFL statistics, and it basically categorizes all of the, it groups like everyone coming out of college usually does this. So it gives a basically standardized test to look at comparison of all the athletes to then draft. This is supposed to be able to indicate how they're going to perform. So then you have the NFL draft. Then they're going to equal the performance in the NFL. Once they retire, they will have a lifetime salary. So the National Football League Combine has the 40-yard dash, the bench press, the vertical jump, the broad jump, the three-cone drill, the 20-yard shuttle, and the 60-yard shuttle. Along with that, they do a Wonderlic score. The Wonderlic score is an intelligence test that is done, and it is not public knowledge, so not taken into consideration in this. Also, they do interviews. Each of the teams are able to conduct interviews with the players that participate. That is also something not categorizable in this study, so is not taken into consideration. Also, they collect the weight and the height of the players, and that is considered in this study. So next, what is the NFL draft? The NFL has 32 teams in the NFL with 7 rounds each, having a pick each round. So 7 rounds of 32 picks each round. As the draft goes declining, there is a declining salary cap for each of those two. So each position can only pay so much. So that means that most teams will be drafting quarterbacks in the earlier rounds because they want to be able to pay them the most. They're also the most paid in their returning years. So what's next? So I started this research when I was a freshman as looking at NFL Combine to NFL Draft. And that is where it all started. So for that research, I took a Z-score to combining all of the Combine statistics together and then correlated that with the rounds. So as you see here, the rounds are at the bottom. The 8th round means they're undrafted. So it was very interesting to see a negative correlation. You would see this and expect it to be seen as you would want to have the higher people who had better Combine statistic drafted earlier than later in the Combine. Also, what was interesting is I found that quarterbacks have no correlation with how the Combine did, as you would probably expect. But on running backs, they had a higher correlation, and there was a correlation there. So that led me to going, what's next? And I looked next at performance. So I decided to take NFL performance and that equaling lifetime salary. Lifetime salary was one easy target variable to project into, instead of taking and combining all the different NFL statistics from rushing to how many touchdowns. And this way it was one way to group everyone together and say, here's one statistic. So the purpose of this was to determine the most important factors that I had in being able to determine the performance of the NFL players using the Combine statistics. So the methods and my data for this study, I looked at first, I had to pull all of the NFL Combine data. I did this using a Python script which pulled all 32 years of the Combine data from NFL Combine reference page, or results. And then, as you can see, that is messy. So I had 32 pages of text files to then sort through and combine. I then was able to clean that data using Excel and put it all into an easy format to then be able to be processed together. So as you see here, I have everything and there's no more craziness. So next I needed to get the salary data. I combined the salary data by using Spot Track. It has all of the players' salaries. It has them for each contract they had, their bonuses, their lifetime salary, multiple things. It groups it by position overall too. So I decided to do they had lifetime salary as a category. So I looked at lifetime salary overall and then took that grouped on position. And the data looks like this originally. But as you see, the positions are not matching. So I have to be able to match them together and had to change the data so that the data would look the same and match the combine information. So then I was able to write a macro in Excel which would take and clean that data and created this easier data to be processed. So then I was able to join both data sets together by looking at both together. So for the combine data, I had 1987 to 2018 NFL data. But for salary, I only had 2011 to 2018. So I decided to take a 10-year back look for the combine and started in 2001 to the future for the combine, which would account for how many people were in the combine and also had my salary data to match with. Between the combine from 2001 to 2018, there were 5,625 participants. So then when joining them together for the salary, I excluded long snappers because there was no join together with that and in the combine data too. So if you had statistics in the combine, but not in the salary, you were included in the study. But if you had a salary, but you did not participate in the combine, you were excluded from this study. So next, my final data set looks like this, where I had joined everything together. I joined both data sets using Excel functions and brought over the salary. So if they had no salary, they obviously didn't make it to the NFL or make any money. So next, for my results and analysis, here you can see a correlation I did as a quick analysis. The dark red is a strong correlation. The dark blue is a negative correlation. As you can see, the straight diagonal, it is matched up with its own. So the three-cone is matched up with its own three-cone. Some interesting ones to look at are the three-cone and the shuttle are highly correlated together. And then you also have weight and vertical leap are highly negatively correlated. But the one I cared about was lifetime salary, so that is in the middle. So what was interesting is the year. That is what was highly correlated negatively with lifetime salary. The year is the year of the combine, so it is the year that the combine happened and it isn't what year they retired or that. So this is interesting because you would expect to see this because if you've been in the NFL longer, you're expected to make more money. So then next, well, that isn't a combine statistic that I wanted. So next I did a feature importance algorithm to then determine what were the most important features in determining this. So I found that these were the top three that bubbled to the top of my study. I had height, weight, and the 40-yard dash at the top. I ran the sample set multiple times, and these three were at the top. As you would expect, most people in the NFL are tall, and they're heavier built, and they're fast. And that's what this also looks like. So what is next for this? So in conclusion, there was no strong correlation between the statistical measures of the NFL Combine and their lifetime salary. So what I would recommend doing is what is the purpose of the Combine? Because if the purpose is to be able to predict their potential and their performance, it's not doing it. So I would suggest potentially changing what those look like and the tests that are done to have a better performance to be able to better predict this. So where does the future look for this? I'm looking at potentially breaking down it into position and grouping it by position to see if there's a better breakdown versus just overall. Next, you could look at colleges and conferences and break that down. One interesting thing I found was just doing a quick run. Alabama had the highest number of people who participated in the combine. So I think it'd be interesting if you kind of looked at how many, what college, or even breaking it down and grouping it by conference. And then if you look at that, then you could take that a step further and combine in the college statistics and see if the college statistics have a better prediction of their salary. Also, a second-year contract would be also something interesting because the rookie contracts are, in fact, set more. The second-year contracts, not second year, they actually are what the people actually would be paying for. You have to bid for the player more than you would have to as in the draft. Also, you have the NFL performance. You could look at those statistics like their rushing yards, their throwing touchdowns. Also, you could look at just right out of the NFL Combine and NFL Draft what their performance is that first year to the first 3 years in the NFL. So, any questions? That's all I have. Yeah.
Have you looked at doing annual salary as a percent of the total cap space, just based on how it's changed over the years, and then also with the rookie contract structure as a percent decreasing recently?
Yeah.
I'm assuming with those being superly heavily weighted towards large rookie contracts earlier, that might have some effect on it.
Yeah, I think it's definitely something cool to consider. I haven't added it into this. It wasn't considered in this stuff. Yeah.
It will be interesting to see with this college paying these college